Fine. So now let us start with the session. Ek minute, let me check. 63 participants. Okay, so let us start with input-output instructions. Okay, we have already covered memory reference instructions and register reference instructions in the previous session. Now, when we talk about our basic computer, uh, talking about computer, it is useless until my computer communicates with the external environment. Okay, and for communicating with the external environment, we need to receive some input from the input devices, and we need to, whatever result is, whatever calculations we carry out, the results are to be displayed on the output devices. Okay, so input and output device plays an important role in our basic computer. We have registers devoted to specifically input and output operations. The two registers which we will be using would be INPR and OUTR, okay, input register and your output register. So first, before moving on to these instructions, we will first see how is actually input output carried out in our basic computer. Okay, first of all, when we talk about an input device, let it be a keyboard over here. Okay, I have my input device. When I am inputting some data to the basic computer, you have a interface in between. An interface which it's a serial interface which helps for controlling the for transferring the data from the input device to your basic computer. Okay, so this is suppose a transmitter interface. It is transmitting data received from the keyboard, received from the input device to my basic computer. Okay, so this is your interface, serial interface. It serially transfers the data. Now, where would this data be stored? We have seen that what is the task of the INPR register? The task of the INPR register, purpose of INPR register is whatever input I receive from my input device would be stored to your input register. Okay, from this register, the data would be going to your accumulator. Okay, we have seen that this data goes, the data from the input register is not transferred to the bus. It goes to your adder logic unit, it goes to your accumulator. Okay, so this is in parallel. AC is in parallel. The interfaces that takes place, that is serial transmission. Okay, now after the data is in your accumulator, it whatever what data would be there in your accumulator, it would be the results after you carry out some calculations over here, right? The results would be stored in your accumulator, or whatever input you are providing would be in AC. Now you want to display this input data to your output, so what will I have to do? Now again, for when you transfer the data to your input register, this controlling of transferring of data is through a special flag called input flag. Okay, we'll be having two additional flags which help us to control the data transfer from the input to your basic computer to your accumulator, and from the accumulator to the output device. Okay, so this FGI is it's a simple flip-flop only. Okay, but it is flag which is used for controlling the input transfer between the input device and your basic computer. Now after the data is there in your accumulator, this data would be transferred to your output device, output register. Okay, this is your OUTR, output register. This transferring again is controlled by another flag, which is output flag. Okay. Now, when you want to transfer the data from the output register to your output device, this is your output device, let us say it is a printer. Okay, now if this data is to be transferred from output register to the printer, again you will have an interface which would be controlling it. This is your receiver interface. Okay, so if I divide this entire transferring, I can say that these two are my input output terminals. Okay, your printer, keyboard are your input output terminals. Here you have, in between you have a serial communication interface. Okay, receiver interface and transmitter interface. And on the rightmost side, we have the different computer registers and flip-flops. Computer registers and flip-flops. Okay, so here OUTR, INPR and AC are our computer registers, and this transfer is being controlled by the two flags FGI and FGO, that is input flag and output flag. And yes, so these are our computer registers and the flip-flops. Okay, now how are these flags controlling this entire transfer? Initially, this FGI is set to 0. Setting FGI to 0 means it is ready to accept the inputs. Okay, so when your FGI is 0, your input from the keyboard is allowed to be transferred to your INPR. Okay, so data from the input device is transferred to INPR only when FGI is 0. It means it is empty right now. Okay, your INPR input register is empty right now. How many bits can I transfer over here? It would be 8 bits. We know that INPR register is an 8-bit register. Okay, so 8-bit ASCII code is alphanumeric code is transferred to your INPR. Now, when the value of FGI is set to 1, at that time only you can transfer the data from INPR to your AC. So transferring from input register to accumulator takes place only when the value of FGI is 1. Okay, it means जब भी FGI की value 1 है, उतने time पे you cannot input any data to INPR. उस टाइम पे INPR में कोई डेटा नहीं जा सकता. Your keyboard strokes would not affect your INPR. वो transmitter interface तक रहेगा, but it will not be transferred to your INPR. Okay, in INPR, data from the output input device will only be received when FGI is 0. And when FGI is set to 1, the data is transferred to your accumulator. Itna clear? As soon as the data is transferred to your accumulator, again, your FGI is set to 0. It means it is ready for the next input. पता चला? The task of flags, they are used for controlling कि कब मुझे data transfer करना है input register के अंदर from the input device. Okay, so in accumulator, you have your input data now. Now, what would happen? We want to transfer this accumulated data to your output register. So here, when FGO is set to 1, okay, FGO की value जब 1 होगी, at that time your data is transferred from accumulator to your output device. Okay, as soon as the data is transferred from accumulator to output device, again, what you need to do, you need to set the flag FGO to 0. Jab value of flag is FGO is 0, at that time only your output register would be transferring your data to your output device through this interface. पता चला? ये output device के साथ transferring कब होगा? Only when FGO is 0. Communication कब होगा? When FGO is 0. Input device के साथ communication कब होगा? When FGI is 0. And accumulator के साथ connection कब होगा? When these are 1s. Will you remember this much? Is this figure clear? These are nothing but simple flip-flop which stores a single bit, and they are treated as flags. Okay, input flag and output flag. And depending upon, so this 0 and 1 is important. Only when FGI is 0, it means it is empty. You can transfer the data from your input device through your interface to this input register. When it is 1, it means it has some data in it. Okay, it has some data in it, and that data is transferred to your AC. Only once the data is transferred to AC, your FGI would become 0, because after transferring, what we do, we transfer the data, we set the value of FGI to 0. Okay, and when we transfer the data of INPR to AC, AC कितने bits का होता है? How many bits? What is the size of AC? 16 bits, right? And what is the size of INPR? 8 bits. So when we transfer the data from INPR to AC in the lower order 8 bits, 0 to 7 में, Here your input value gets transferred. Understood? So in the lower order bits from 0 to 7, the data from your input register gets transferred to your accumulator. Is this figure clear? And the role of FGO and FGI. When we transfer data from accumulator to output register, at that particular time your FGO is 1. But एक बार output register में आ गया, उसके बाद only when it is set to 0, when FGO is 0, your data would be transferred to your output device. Okay, so as soon as you transfer your data from accumulator to your output device, output register, you need to set the FGO to 0. Okay, so that FGO is set to 0 when the data is transferred from accumulator to output register. So now quickly let us see the instructions. Input output instructions. So this was the figure which you need to keep in mind, the way in which the transfer of data from input output devices from and to input output devices take place, the way in which our basic computer interacts with the external environment. Okay, so now quickly let us see the input output instructions. Here we know that when can an instruction be called input output instruction? When D7 is 1. Okay, your opcode is 111. Your I value should be, what should be the value of I? 0 or 1? 1. 0 was for register reference instruction. The value of I is 1 for input output instruction. Okay, so D7 I. Okay, and when does this input output instruction take place? At which timing signal? T0, T1 for fetch, T2 for decode, and T3 is for executing the instruction. Okay, so D7I T3 would remain common to all the input output instructions. Let us name it as P. उसमें हमने R नाम दिया था. Here we are naming it as P. So this will remain common to all the input output instructions. Okay, now my instruction would depend upon what? It would depend upon the bit of IR. Okay, which bit? The bit located from location 6 to 11. Okay, because here वो 0 to 11, यहाँ पे we do not have so many instructions, only from 6 to 11. Okay, 11, 10, 9, 8 and 8, 7 and 6. ऊपर register reference में we had many instructions, 0 to हमने 11 लिखा था, ठीक है? Here we are using only the bits, higher order bits, 11, 10, 9, 8, 7, 6. Okay, so this is what? 12, 13, 14, 15. So first group we are using, that is fixed for all, 1, 1, 1, 1. And then the remaining, this is one set, this is second set of 4 bits, and this is third set of 4 bits. Okay, so all these would be zeros only. पीछे के 6 bits 0 रहेंगे. Okay, and we have 6 instructions over here. When 11th bit is 1, we call it B11. Okay, so which is the instruction that takes place at PB11? PB11 means what? The first 4 bits are 1. 11th bit is 1. Remaining all are zeros. Okay, this is PB11. So at PB11, which instruction takes place? INP. What is this INP instruction? INP instruction is input a character. Where is the character inputted from? It is input from the input device. Okay, so what takes place? Let us talk about the input instruction right now. So what do we have to do in PB11? If I want to specify it through my register transfer language, how would I write? From input device, we will be transferring from our INPR. Okay, whatever is in my INPR, that data will be transferring it to the accumulator and we'll be setting the FGI to 0. Okay, this is what we saw in the previous diagram. Yes or no? How does a character get inputted? Whatever it has, whatever INPR has received from the input device, it would be in this INPR. When would INPR receive data? When your FGI is 0. ओके अब यहाँ से जब डेटा आप अपने एक्यूमुलेटर में ट्रांसफर करोगे, कब ट्रांसफर होगा? व्हेन FGI is 1. Okay, when FGI is set to 1, the data would be transferred. And as soon as your input character is received, you again have to set FGI to 0. Okay, so this is your first instruction. Second instruction is OUT. It is at PB10. Okay, OUT is output character. So in this, what we will do is, we'll be transferring the data from our computer, that is accumulator, to my output register. Okay, so here the instruction is OUTR, transfer the data from accumulators 0 to 7th bit to your output register and set FGO to 0. As soon as you set the FGO to 0, what would happen? Output register से receiver interface के through data output device में जाएगा. Okay? Third instruction is SKI. SKI stands for skip on input flag. यानी जब भी input flag की value 1 है, skip the next instruction. Okay, so this is PB9. In PB9, what we do, we check the value of the input flag. If the value of input flag is 1, what we need to do? We need to skip the instruction. So PC equals to PC plus 1. Okay, similarly, the next instruction is SKO. Skip if output flag is 1. Okay, so again, this is PB8. पहले दो instruction, input, output, input character, output character. Then the next two instructions, skip if input flag is on, skip if output flag is on. Okay, this is how you'll be remembering it. Okay, so this is, we will be checking the output flag. If the value of output flag is 1, then what we need to do? Skip the instruction. How can we skip? Just increment the value of PC. And last two instructions of IO are ION. ION is interrupt enable on. Now you don't know what is interrupt, right? Interrupt enable on. We will be studying this interrupt in the next session in detail. Interrupt means what? Anytime whenever your computers gets, now here it's not fixed at which time the user will be inputting data to the machine, right? So whenever whenever communication takes place with any external environment, either for outputting the data to the system or receiving input from the system, okay, a special signal is takes place, and that we call interrupt. We'll be discussing about this interrupt in detail, but we say that an interrupt is generated. ठीक है, जैसे ही कुछ डेटा आया बीच में से अचानक, we call an interrupt is generated. Okay, so this is what we'll be setting the interrupt, we'll be enabling the interrupt, and this interrupt is controlled by a flag called IEN, interrupt enable. Okay, this is instruction PB7. What we will do in this interrupt enable on, we will just be enabling this IEN flag to 1. It means कुछ interrupt आया, IEN की value 1 हो गई, means what? There is some interrupt. Okay? And the last instruction is IOF, that is interrupt enable off. PB6. Okay, here also what we do? Here IEF flag is set to 0. ये काम खत्म हो गया. Now again the interrupt signal is set to off. Okay, so this is your interrupt enable off. These two instructions you will get to understand better once we study the program interrupt and the entire interrupt cycle. Okay, but that I'll not be covering today. We'll be doing it in the next session. So are all these instructions clear? How does input output takes place in the basic computer? Okay, and so that figure was important. Serial, we have uh, two serial interfaces. One is receiver interface and the other is transmitter interface. Okay, and these two flags for controlling. It's not IEF, it's IE. कहाँ मैंने IEF लिख दिया कहीं? It's IEN, interrupt enable. Did I make a mistake somewhere? Oh, sorry, that's not IEN. It's IEF. It's IEN. Okay, this is a flag interrupt enable. When at this particular time, ION instruction is setting this flag to on. It means some interrupt is received, and IOF is interrupt enable off, in which the IEN is set to 0. Okay, so these are the 6 instructions of input output category which you need to remember. Okay, this would be common for all the IO instructions, D7, IT3, and then the two instructions, one INP OUT for inputting a character, OUT for outputting a character from the accumulator to the output register. Then the two instructions, skip if your FGI is 1, skip if the FGO is 1. Okay, and the last, interrupt enable on and interrupt enable off. So now if you have any doubts in the input output instructions, so now we have covered all the 3 categories of instructions: register reference, memory reference instructions, and input output instructions. So if you have any doubt in this, you can ask me. Okay, interrupt will be covering it in the next session.